Hello student. Today in this video I'm going to talk about a distributed information system. The example of this distributed information system is Google search engine. So I found an article in internet. It says the anatomy of a large-scale hypertextual web search engine. The title of this paper is a bit uh, using big words, but don't worry, it does not give any more higher research terminologies, but just a basic terms about it. Means suppose it just this paper just deconstruct, or it just gives a basic layman idea about the Google search engines, that the search engine we use every day at every time for at every work. So let's search. Actually, I'm not going to give a very elaborate lecture on this, but I will draw some attention on few points of this Google search engine to motivate you in regard of distributed information system. Means to design such a system, what we need to know to design such a system, what we have to do, like that thing we that is why I try to make this video and give you some hint about that. Now first, I will not go through everything in this research paper in this video. I encourage you to go through this. It will be very helpful to build few knowledge about Google search engine, but I will give some definite and interesting topic about this. First, see this one. This one is the basic architecture. Okay, this one is a basic architecture of Google search engine. So just go through these components. There are URL server, crawler, storing server, there is a repository, there are indexer, URL resolver, barrels, links, doc index, PagerRank, searcher, lexicon, anchors. So I am giving just the namings at first because we will go through details in this paragraph. So here you can see first it starts with a few very interesting note. Most of Google uh, is implemented in C or C++ for efficiency and can run in either Solaris or Linux. So C, uh, if you are learning C or C++, see how much it can be useful. Google can be built using C or C++ and in Linux. So we can also build such type of engines if we go through the deep of these topics. Okay, so then again, uh, in Google, see here, I'll go through this text so that you can understand this architecture first. The web crawling is done by several discrete crawlers. Here, these are the crawlers. Crawlers are a program which crawls through different web pages. Suppose here, if I suppose this is the text I have put down here. So when I put down here some queries, okay, then the crawlers will go through different web pages like this, like this, like this, like this. There are the different web pages. So it will go through different web pages. Okay, so again go to that. So in Google, web crawling is done. Crawling means it just walk through different distributed by several distributed crawlers through different URLs mean the web addresses, those www.something.com, www.something.in, www.something.org. So there will be lots of URLs in the web, and the crawler will go through every one of them simultaneously. So there will be lots of crawlers live on the internet at every time. So, and second, there is a URL server. This is a URL server. This is maintained, means there is many numbers of web pages throughout this world, throughout the servers exist in this world. Those web pages, the URLs only, kept record in this URL server. So there is a URL server that sends list of URLs. It sends a list of URLs to the crawlers. The web page that are fetched means the crawler will fetch some pages. Okay, URLs to be fetched to the crawlers. The web pages that are fetched are then sent to store server. Whatever result they got, they will store it on the storage server. Then it will compress. The store server then compresses and store the web pages into repository. It compresses the data because the data that crawler finds in different web pages might be huge, lots of data. So that data will be compressed and will be saved in repository. And after that, it will every web pages found by crawler will given an ID number, and called every web page has an associated ID number called doc ID. So every document has an ID which is assigned whenever a new URL is parsed out of a web page. Means whenever you create a new web page, and web ID and doc ID will be created in the repository. So then the indexing function is performed by the indexer and sorter. So here you can see this is indexer and sorter. This will sort and index every pages. Okay, it will give some indexing numbers. It will sort in a suppose a numerical order or in a alphabetical order at their specific way. Okay, it reads the repository. So the indexer and the sorter will read the repository. Okay, it will parse them. Okay, each document is converted into a set of word occurrences called hits. So every document will be deconstructed in word, and whenever you give any phrases in Google search bar, then if any matches found with those word, then it called hits. The hits record a word position in the document. Again, I am going to show an example here. Here again you can see when I give this phrase in the search bar, you can see here it's showing these words also, the position of the word. Okay, so this is what it is saying. So this is a basic idea about this architecture, how the function is going on. So why I'm discussing this thing is that these all things are distributed. All this is a different component, this is a different component, this is a different component. All things are different, but they are communicating with each other in a distributed manner, and they are executing one single task to search out your query. Now how the query will be done, how the query will be searched, here you can see it will parse the query. So then convert words into word IDs. As I discussed earlier, every word will be assigned an word ID. Seek to start the doc list in short barrel for every word. Here you can see there are barrels, means for every word you put in the search bar, every word will be put in these barrels. Okay, in that way every word, that doc list, seek to start doc list means document list. Doc list means document list. There will be a list of documents already present, list this already present in the repository in the sort barrel for every word. Scan through a doc list until there is a document that matches all the search terms, means matches with every word that you are putting in the search bar. And again, it will not only give every pages that it will find, it will give only those pages which gives most rank, means some pages has high rank and some pages has low rank, and those thing ranking is also done through a system. Please go through this also. Okay, please go through this also for more understanding. I am just giving a basic hint out of all this. It will compute the rank of the document. If it is high, then only it will fetch to you. If we are in short term barrels, means the number of words you are giving to the Google is more than the number of barrels, then it will at the end of any doc list seek to the start of the doc list, then it will go again to the first of the doc list. Okay, it will again start from the starting and in the full barrel for every word and goes to step 4. Again it will go to step 4. So this will go along for every word you given to the search bar. So ultimately you will get the document. And again I can see you like show you like here, if I write this gives, these are the possible outcome. Okay, so this one is the highest ranking for my search phrase, so this is giving the highest rank. So if we put some other word, it will give a different page. Suppose if I put PDF, it will give a different page. If I remove this one, it might give this again, but at some point of time, suppose 1 year after or 1 year ago, this might not be the same rank, it might goes down also. Okay, so that way it has been done all the way. Again I want to show you one thing here. Here this is about how the crawling is done. Actually you can read this. In order to scale to 100 million web pages, means if the Google want to reach 100 million web pages at a time, Google has a fast distributed crawling system. This is the main part I am talking about. A single URL server serves list of URLs to a number of crawlers. Means the crawler will get these URLs. Okay, suppose typically run out of 3. Both URL server and the crawler are implemented in Python. See, this is a new thing you can learn, that by using Python that crawler can be created. So each crawler keeps roughly 300 connection opens at once. Means suppose there is 3, every 3 will be keep 300 connection at once. This is necessary to retrieve web pages at fast enough pace. At peak speed, the system can crawl over 100 web pages per second using 4 crawlers. See, this is the interesting thing. Okay, this is the interesting thing you need to learn, or if you want to learn, go more deep about this. Okay, again I'm to show one more thing, that is about stories here. um, here you can see total size of fetched page means whenever, suppose every day, suppose it is an example, actually this table is an example. Suppose there are number of pages, the size of the pages containing in the www or World Wide Web is size is 147.8 GB. Then in the repository part or in the repository section, it will compress those data into 53.5 GB. Okay, so there are these are different type of terms. You can go through it. Means different type of servers containing different type of information. Means short inverted index is 4.1 GB. This is an technique to store these 147.8 GB. To store this 147.8 GB, we can use 4.1 GB also. Full inverted index, we need to have 37.2 GB. Using lexicon, we need to have 293 MB. So in this way, everything here, every servers, every part, see here there is lexicon, okay, there is indexer, there is repository, so everything is actually server, so it needs storage. So main 147.8 GB is divided, or everything is stored in different servers in those amount of storage space, So here you can see one interesting line: with better encoding means compressing, as you use in today's video and image format. We use JPEG format, we use MP4. There are different type of 3 GB videos, there are MKB videos, there are different type of video format. Actually those are basically compressing technique. So in this scenario also they use some compressing technique. So with better encoding, and compression of the document index, a high quality search engine may fit onto a 7 GB drive of new PC. See here, using only 7 GB of your PC, you can build a high quality web search engine like Google. Okay, so this is the interesting thing. I'm talking about Google search engine. So these things can be done using few known techniques, but we have to go more deeper to learn the data sets, the data structure it is using, the technique they are using, the technique to compress, the technique to rank. These all the things are here. I'll give you this in the Google Classroom. Please go through this. Actually this is an example, very good example for distributed architecture. So I'm just giving this video to you so that you can learn a bit about Google, also a bit about distributed architecture also, and you get some motivation about how we can build a search engine. That's it. Thank you, and go through this if at your free time. If you have any doubt, please ask me, because I also don't know many things about this, and if you ask me some questions, I can give you some answers, and at least I can try for those answers. So thank you. Goodbye.